So now we're starting the next portion of our computer systems unit, and that portion is called number systems. And we're going to dig into the idea of different representations of numbers. We're going to start off with something you already know. The decimal number system. This is the number system that you've been using since you first started to count way back when you were 1 or maybe 2 years old. When you started in school, they started to teach you how these things work. They would teach you things like, this is the ones column, this is the tens column, this is the hundreds column. And that's the way you were taught, and that's fine, it's great. But they didn't teach you the underlying meaning behind why it's the ones column, why it's the tens column, and why it's the hundreds column. And we're going to look into that today so you have a better understanding, because we're going to then apply that to different number systems that don't just have the values 0 through 9. So this system, the decimal number system, also goes by another name called the base 10 number system. And the reason why is because it uses 10 digits, 0 through 9. All the numbers in the system are less than the value of 10. All right, now we can create any number we want using these digits, but those are the only digits allowed to us. That's fine. Essentially, each column in your number system, each column in your number represents a different power of 10, hence the term base 10. So let's take a look at this for a second. If I have, let me pull up my pen here. Oops, whoa, I'm getting a little excited. What is going on here? Back up. Let's try this pen here. So if I have a number, let's say it is 217. Now, we all know how to read that number. We know that the 7 is in the ones column, the 1 is in the tens column, and the 2 is in the 100s column. But where does that actually come from? Well, think about this. 1, 10, and then 100. Well, what are those? Those are all just powers of 10. 10 to the power of 0 is 1. 10 to the power of 1 is 10. And 10 to the power of 2 is 100, and we continue on forever and ever. Thousands column, and so on and so forth. So that's where this number actually comes from. Is there any eraser on this thing? I don't know if there is. Let's find it. Click. Maybe. Oh, there we go. Undo. That's nice. All right, so that's all we have to do there. Let's take a look at the example that I have for you. So the powers, as you saw me number them, they number from the right to the left, the least significant digit. So the 7 was the least significant digit because it's only worth 7. It's the ones column. Whereas the 2 was the hundreds column, so it's worth 200. It's worth more. So looking at the example I have below here, 394, you can see how the number breaks down. And this is where these numbers actually come from. You have 4 in the 10 to the power of 0, 4 in the ones column. You have 9 in the tens column, and you have 3 in the 100s column. So we end up with 300 plus 90 plus 4. That gives us our 394. Now that's how you learn numbers. Great. We're going to keep this idea, and we're going to use it going forward. In fact, we're going to use it a lot going forward. Pro tip: when using number systems, we must state the base of the number that state the base when writing it. So for example, we don't just write 394, we write 394 bracket subscript 10. And the reason why we do that is because if we're working in multiple number systems at the same time, we need to make sure that we know which number belongs to which system. And you're going to see that in a second, why that's a problem. So the binary number system, this is the number system that computers understand. It's the only thing that computers understand. It's also called the base 2 number system. And that's because it only consists of zeros and ones. We talked about this in previous lessons. So let's think about that for a second. If I write the number, where's my thing? If I write the number 101, you guys think of it as 101. And that's correct if it's in base 10. However, if I write 101 base 2, it has a completely different meaning. It doesn't mean 101 anymore. In fact, it means 5. Yeah, 5. I had to go over that in my head. So that's a completely different thing. That's why we have to go back. The undo's not working anymore. Oh, there we go. Okay. So that's why we have to be careful when we write different numbers. We have to make sure that the reader knows which number system we're working in. We can't assume that they always know. So here's a little example of a binary number, 110 base 2. And that's how we would read that number. We wouldn't read it as 110 or 110. We would read it as 110 base 2. So this time each column doesn't represent a power of 10. Each column represents a power of 2. But we still calculate its value in the same way. We take each placeholder value and we multiply it by that power, just like we did in the previous page. If we look at this, the 4, which is the placeholder value in the ones column, was then multiplied by the 10 to the power of 0. And then we did that for each placeholder with the appropriate exponent. Now we're just going to do the same thing over here. And that's it. So converting binary numbers, which are in base 2, to decimal numbers in base 10. Very simple. We're going to follow a few steps, and these steps will actually work to convert any number system to decimal, not just binary, absolutely any number system. So keep that in mind going forward. So this is what we're going to try and convert. We're going to try and convert that 110 base 2 to something in base 10. Step number 1. Number the columns from right to left starting at 0. This is your power value. This is our column representation. 0, 1, 2. Easy peasy. Step 2. We're going to drop each placeholder digit down, and then we're going to multiply that digit by the base you are in. So currently we're in base 2. And we're going to put that base to the power value of the column. Now, that sounds confusing, but when you see it, it's actually pretty straightforward. We drop the number, and then we multiply it by the base we're in, which is 2, to the exponent of the column we're in, column 0. Now, 2 to the power of 0 is a 1. Anything to the power of 0 is 1, but we're multiplying it by 0, so it's 0. Looking at the next column, it's the same idea. So there's the base, and then there's the exponent. Now we continue this process. We drop the 1, the placeholder, we multiply it by the base to the exponent of the column we're currently in. 2 to the power of 1 is 2. Multiply that by 1, we get 2. We repeat it again. Drop the number, multiply it by the base to the exponent, and this time we get 4. 2 to the power of 2 is 4. And then the final step, just add them up. Add up all your products, and you should end up with your final number, which is a 6. In base 10. Notice that I actually wrote the brackets in the base. It's very important that we do that. Okay, that's it. That's all you have to do. So now you try. I want you to pause the video for now. You have all your rules up at the top there to follow. Pause the video and try and solve these two problems. I'm going to do Jeopardy theme in my head while you guys go do that. All right, I'm assuming you're back now and that you've given it a go. So let's go through this together real quick and actually give it a shot. So first thing we do, step number 1, it says number our columns. So we have 0, 1, 2, 3, 4, and 5. Now step 2 says drop the number. So I'm going to drop the number. That's 1 times my base that I'm in, which is 2, to the power of my column, which is 0. Well, anything to the power of 0 is 1. Multiplied by 1, that gives me a 1. Next column. We have 0 times 2 to the power of 1 this time. And 2 to the power of 1 is 2, but it's multiplied by 0. So we get a 0. Now I know what you're going to ask. You're probably going to say, if there's a 0, the answer is always going to be 0. So can I just write 0 and skip the step, Mr. Lane? You know what? Normally I would say, yeah, go for it. But you're just learning. And the problem with that is that students constantly make the mistake of when they skip that, they mess up the numbering of their columns. And all of a sudden it goes from 0 and then you're doing the 1 in the wrong column. Or you're doing the 2 in the wrong column. And you end up with an incorrect result. So I would be erring on the side of caution for now and just write them all out. It only takes you a second. So we drop the 1. We multiply it by 2 to the power of the exponent, which is 2 this time. 2 to the power of 2 is 4 times 1. And we continue the process. We have 0 times 2 to the power of 3, which is 8, but it's 0, so we still get 0. And we get the next ones. We have 1 times 2 to the power of 4, which is 16, times 1 is 16. And finally, whoosh, we have 1 times 2 to the power of 5, which is 32, times 1 is 32. So we have all that. We add them up. So we have 16 plus 4 is 20, plus 32 is 52, plus 1 is 53. And that is in base 10. All right, hopefully you got the same answer. Let's go try it over on the other side. Same idea. First thing we do is we number the columns. 0, 1, 2, 3, 4, and 5. Now we start dropping. 0 times 2 to the 0. Well, that's going to give us 0 because we have a 0. We have 0 times 2 to the 1, which is going to give us 0 again because we have a 0. Now we should start getting some good values. We have 1 times 2 to the 2, which is going to give us 4. You guys are going to get really good at your powers of 2. 1 times 2 to the 3 is going to give us 8. 8, I swear that's an 8. I'm kind of writing on an angle right here. 1 times 2 to the 4. I'm leaning over to get to my drawing tab. It's too far away. Bad ergonomics. Which is going to give me 16. And then finally, whoosh, we have 1 times 2 to the 5, which is 32. You'll notice that I line them up. That makes the adding much, much easier. So I have 32 plus 16 is 48, plus another 8 is 56, plus a 4 is 60 to the power of 10. So hopefully you ended up with both of those answers and you're much better off for it. Okay, moving on. Not much left. We're going to reverse the process. What if we already have a decimal number and we want to convert it back to binary? Believe it or not, this does happen. Now, the previous process, I taught you that you could do that with any number system, and you can. So if we were converting a base 6, for example, to a base 10, instead of multiplying by 2 to the power of something, we'd be multiplying by 6 to the power of something. The same thing works when we're going the opposite direction. This time, if we're multiplied to get to decimal, if we're coming back, that means we got to do the opposite operation, which is divide. And it all depends on which number system that we're going to. Now, in this case, we're going to go to binary. So we're always going to be dividing by 2. We're dividing by the base that we're going to. If I wanted to go to base 6, for example, I would divide by 6. So reverse it. We can go from decimal to any number system by dividing. Let's try it out. Step number 1, divide the decimal number by the base we are going to. So let's start with that before we get into that next part of that sentence. So if we have 91, I want to divide by the base we're going to. In this case, we're going to binary, which is base 2. So 91 divided by 2 is 45. Now we're not doing 45.5 here. We're just thinking whole numbers because we're worried about the remainder. Remember long division? It's been a while since you've done that, I'm sure. 91 divided by 2 is 45. Well, what's left over? Well, how do I get the remainder? Just multiply that 45 by the number you divided by. So 45 times 2 is 90. So if we take away 90 from the original 91, we have 1 left over. So that's where the R equals 1 comes from. So reading the next part of that sentence. So it says, divide the decimal number by the base we are going to. The remainder after the division will be the next number in our end result. So that 1 is going to be the first number in our final answer. So every time we get another number, we're going to place it to the left of that number. It's always going to go from right to left. Okay? So the next step, the second step I should say, is to take the answer from our previous division. Let's see if you guys remember what the answer is called from a division. It's a quotient. So we're going to take the quotient, and now that's our new decimal number we're going to divide by. So we're going to take that 45, and we're going to divide it by the base we're going to this time, which is 2. 45 divided by 2 is 22. Obviously, it's 22.5, but we're going to ignore those decimals. So 22, and we have a remainder of 1. 22 times 2 is 44. 44 out of 45, and we end up with 1 left over. So now we have 2 digits of our final answer. And we just repeat this process. We repeat steps 1 and 2 until we get to the end. Well, what is the end? Well, you'll see. So the end is whenever our quotient is a value of 0. Our quotient, the result of the division. And that is going to be our last step in the process. That step counts. We don't ignore that step. But that is when we are done, when the quotient is a value of 0. So we're going to go again. We're going to say, okay, now 22 divided by 2. Well, that's 11. This time there's no remainder. 11 times 2 is 22. So we used up all of the 22. So remainder is 0. Repeat again. 11 divided by 2. That's 5. 5 times 2 is 10. So that means that there's 1 left over. 5 divided by 2. Well, 2 goes into 5 2 times, and there's 1 left over. All right, now we're doing 2 divided by 2. 2 divided by 2 is exactly 1. No remainder. 1 divided by 2. Well, 2 doesn't go into 1. So the answer is 0. But nothing used up that 1, so there's still a remainder of 1. So that's our last step. Pro tip. Notice how I wrote everything on a slant from top right down to bottom left. That was intentional. Now that I did that, so I don't make a mistake, I just drop all of the numbers perfectly vertically down, and that will give me my final answer. The biggest problem, or the number one mistake students make in this, is they just stack it one on top of one another, all their answers, and they end up writing the final answer in reverse order by accident. Okay? So if you do stack them, I'm not going to take off marks from that, but if you make an error in your final answer, you will lose marks for that. So if you do plan on stacking them, just remember your first number that you get, your first remainder, is your rightmost digit. And every digit after that goes one next to the left, as you can see with the drop-down arrows. And that's the whole process. Now it's your turn. Pause the screen, and let's see what you come up with. All right, you back? All right, let's give it a go. So let's say we have this 72, and we want to figure out what it is in binary. So that means every single step, we're going to divide our decimal value by 2, because that's the binary number, or that's the base that we're going to. So I have 72, and I'm going to divide that by 2. Well, that's exactly 36. 36 times 2 is 72. So since it's exactly 36, that means I have a remainder of 0. Next step, 36 divided by 2. Well, that's exactly 18. So I have a remainder of 0. 18 divided by 2. Well, that's exactly 9. So again, I have a remainder of 0. 9 divided by 2. Well, that doesn't go in evenly this time, but it does go in 4 times. 2 times 4 is 8, which means there's 1 left over. So I have a remainder of 1. So we go again. 4 divided by 2. 2 goes into 4 exactly 2 times, and we have a remainder of 0. 2 divided by 2. Well, 2 goes into 2 exactly 1 time, and we have a remainder of 0. 1 divided by 2. 2 does not go into 1 at all, so the answer is 0, which means this is our last step, but we didn't use this one, so we have a remainder of 1. So we're all done. We just need to drop our numbers down now. So we got 0, we have 0, we have 0, we have 1, we have 0, we have 0, and we have 1. So our final answer is 1001000 base 2. That's it. That's the whole process. If you have any questions, send me an email, and hopefully everything works out.